In this video, we're going to do a brief introduction to square roots and specifically talk about how to find square roots of perfect squares. So let's start the study of square roots by looking at an expression that contains an exponent, because square roots and expressions that are raised to the second power are related. So if we have an expression like 3 raised to the second power equals 9. Well, this is an exponential expression where 3 is the base of the exponential expression and 2 is the exponent. But what you may not have known is that 9 is a perfect square. 9 is a perfect square because it is 3 squared, or 3 times 3. So a perfect square is the result of multiplying any number times itself, or the result of squaring any number. So 1 is a perfect square because it's 1 times 1, or 1 squared. 4 is a perfect square because it is 2 squared. 16 is a perfect square because it is 4 squared. 25 is a perfect square because it is 5 squared, and so on. But what if I ask you to take this perfect square, in this case 9, and undo that? In other words, undo the square that got us to 9. That process is called finding the square root. The process of finding the square root of a number is the process of finding a number that when we square it gets us the perfect square. So in this case, although we're used to calling 3 the base of the exponential expression, we could also call 3 the positive square root of 9. Okay, so what is this meant to show us? The process of squaring a number or raising a number to the second power and the process of finding the square root of a number are opposite processes. Just like addition and subtraction are opposites, multiplication and division are opposites, squaring a number and finding a square root of a number are opposites. They are opposite operations. So we say the process of finding a square root is the process of undoing a square. And it turns out that all positive numbers have 2 real number square roots, one that is positive and one that is negative. Now, 0 doesn't count in that because obviously 0 is not a positive number. It's a neutral number. 0 only has 1 square root itself because 0 times 0 is 0. So if I were to ask you to find the 2 square roots of 121, that means find the 2 numbers that when I multiply them by themselves, we get positive 121. Well, the first and most obvious solution to this is 11. 11 is the positive square root of 121 because 11 times 11 is 121. The negative square root of 121 is negative 11 because negative 11 times negative 11 also gives us positive 121. So all positive numbers have 2 square roots, one that's positive and one that's negative. Let's find the 2 square roots of 225. Remember, because this is a positive number, there will be 2 square roots of this number, one that's positive, one that's negative. 15 times 15 is 225, and negative 15 times negative 15 is also 225. So 15 and negative 15 are the 2 square roots of 225. Again, notice one's positive, the other one is its opposite, or negative. Now, as mathematicians, you know we have to have a symbol to express every idea. So to express the idea of square roots, or to express that we need to find a square root, we use the radical symbol, which is this guy. And the number that we want to find the square root of goes underneath that radical sign. That number that we're trying to find the square root of is called the radicand. Now remember, there are two square roots of every positive number, one that's positive and one that's negative. The principal square root is the positive square root. So if you hear me say, find the principal square root of a number, we're only looking for the positive square root of that number, not the negative one. So although 11 and negative 11 are both square roots of 121, only 11 is the principal square root. So how do we notate that using math language? Like, how do we know if we're only looking for the principal square root? If we see an expression like this means give me only the principal square root of 121, which would be positive 11. But if we see the square root notation with a minus sign out front, that means only give me the negative square root of the radicand. So in this example, we would be looking for the negative square root of 121, which would be negative 11. So if we just have square root notation without any sign in front, that means give me the principal or positive square root of that number. But if we have a negative sign in front of the radical sign, that means give me the negative square root of that number.